So we're going to spend about 45 minutes today talking about temperature management from harvest into the plant. Rudy's talked to you a lot about what goes on inside the plant, and I'm not going to cover that area. But temperature management is absolutely crucial. You're going to hear this concept throughout the 3 days. Now let's take a look at the methods that are available for cooling the product. The first and most versatile is called forced air cooling. This is where we take cold air inside of a cold room and cause it to move through the product itself. Okay? Now a lot of times when you put product in a cold room, you would assume that, well, it's going to cool, right? Because it's warm product in a cold room, and it will usually. About the fastest you can cool product, just sitting it in a room itself, is about 24 hours or so. If we can take that cold air and force it past the product, now we can reduce our cooling times to within hours. And that's what forced air cooling is about. You can see here there are two lanes of product, just in, looks like pallet bins in this case. It can be any sort of form. There's this empty space between them, and then a fan evacuates air from that empty space. The tarp in red covers the empty space, so the air that's evacuated has to be replaced by air that flows through the product. It's a simple concept. Here you can see a picture with strawberries. You'll see the fan in the back. The tarp is black. It hasn't been unfurled yet, but it will be rolled out, cover that open area, and the air will flow through the berries and return to that fan, be recooled, and then the air is recirculated in the room. And this is a picture with the tarp in place. The fan is on. You notice how the black tarp is kind of sucked down because of the negative pressure in that return column. There's a lot of details on designing the forced air cooler in terms of air supply area, air return areas, airflow rates, static pressure, refrigeration amounts, and things like that. And all those details are given in the Commercial Cooling of Fruits and Vegetables and Flowers book, which you do have a copy of in your bag. And forced air cooling is covered quite completely there with a lot of the calculations and background information. Any questions about forced air cooling before I move on? Okay. Moisture loss. We do lose moisture in forced air cooling. This is a graph of some experiments we did with carrots many years ago. And you can see that the amount of moisture lost varied from about 0.5% of the weight of the product to 1.5% of the weight of the product. And the amount of water depends on the total temperature drop in the cooling operation. Okay? And that's the only factor that influences it. Those blue and yellow dots are high-speed versus low-speed cooling. 0.5 CFM per pound versus 2 CFM per pound. And you can't see a difference around that line. Some people have this idea that if you move the air fast over the product, you're going to chill it, damage it, burn it, something like that. And the answer is no. There is only one example of a commodity I've ever seen that's damaged by fast forced air cooling, and that's a few varieties of stone fruit that are subject to inking problems, and fast cooling will exacerbate the inking. But other than that, we can run very high speeds of air over the product and not have any effect on the moisture loss. The rate of moisture loss, the amount, is dependent on how much temperature we remove from the product. Okay?